Hello, my name is Marcel Green, and the following is a brief overview of my project at the midterm timeframe. The overarching goal of my research is for the advancement of a screening process for materials to be used at hypersonic relevant temperatures. In summary, the optimization of measurement and control parameters for extreme temperature mechanical testing systems is my primary goal. This project has been under the advisement of Dr. Brady Butler, Daniel Lewis, and Nicole Person. I'd also like to thank my project sponsor, the National Science Foundation, and their grant for making this project possible. Before diving in, I'd like to distribute the information on our background for this project. The United States Department of Defense is aiming to minimize obstacles regarding the availability of materials and testing in high-temperature environments. Areas such as actuation, measurement of load, and associated strain require specific attention to address the challenges assessed by the National Academy's Defense Materials Committee. In order to optimize the measurement, control, and analysis capabilities of this project, I'm working towards the development of a targeted focus in the form of a multi-scale test system. The accomplishment of the targeted goal of evaluating the actuator, measuring load, and measuring strain is made possible through a compartmented research focus. In regards to actuation, we have the instrumentation and measurement aspect, which is instilled through the hands-on portion of my project, in which I'm able to work with hardware, including the wiring of a terminal, as well as the distribution of power through a power supply, for the completion of a circuit through which my tension testing system is able to be accomplished. Secondly, we have the measurement of load. This part of my project is through the control of the small-scale tension system in the form of software platforms such as LabVIEW, as well as technology in the form of a forward-looking infrared camera in order to record the associated data. Lastly, we have the analysis of the measurement of strain. Through varying inputs in the relevant equipment software, not only can I adjust parameters and streamline the process in the simulated format, I can also provide data for multiple uses. The image shown here is the initial care package received of the small-scale tension testing system that correlates with my focus on actuation, as it allows for the manipulation of desired conditions in this smaller system, as you can see here. Instrumental actuation is completed in the form of the hands-on configuration of the small-scale testing system. This is the current state of the equipment as I am currently completing the loop of the system back to the software platform to be controlled by the user. On the left-hand side, this spring terminal was wired by differential pairs by myself through the pinout provided by National Instruments. The image captured here is of the multi-scale test frame configuration that I'm using that allows for hands-on control of this materials science system. As I apply stimuli in the form of varying inputs, I'm able to test for a response that allows for the measurement of load and therefore increasing the accuracy of our screening process. Again, the objective is to expand measurement, control, and analysis capabilities. The expansion will be achieved through the implementation of the measurement of strain in conjunction with the multi-scale system. As shown here, the miniature tensile samples are what are utilized to provide a more comprehensive approach to address the challenges of our screening process. The software platform for the testing system allows for continuous measurement and logging. I am currently working on making this more detailed and catered to the user's inputs, as the screenshot on the left is the program in 2018, whereas the screenshot on the right is the newest update for 2023. The camera control software shown here provides the tracking of the load applied and strain measurements as it is monitored through optical methods in the form of the software shown here. In the right-hand screen, you can see the capture of my camera view. Going forward, the four main points that you've seen here include the assessment of the boundaries of actuation, the enhancement of the precision and dependability of our mechanical properties, as well as the implementation of the Python programming language for the adjustment and automation of system parameters. Thank you to both of the institutions shown below and for being a part of this presentation.